Welcome to our last lesson in Chapter 7, Solve Right Triangles. That's my husband in the background. He wants to be part of the video. So now we're going to use inverse tangent, inverse sine, and inverse cosine ratio to find all missing angles and lengths of right triangles. In our warm-up exercise today, side PR, which is the hypotenuse of this triangle, is 12. And the measure of angle R, so that angle there, is 19. So I'm going to be using the adjacent over the hypotenuse. And if you remember from SOHCAHTOA, CA, C-H-A, is where I have adjacent divided by hypotenuse. So that's the cosine of 19 is going to equal the adjacent, which is P, divided by the hypotenuse, which is 12. So using my scientific calculator, which you can't see because I'm using my iPhone, I'm going to do 19 cosine. The cosine of 19, so I'm going to erase cosine 19 there, is 0.9455. I'm going to multiply that by 12, and I get that P is equal to approximately 11.346, which is going to round to 11.35. They rounded to the nearest tenth and got 11.3 because 11.34 would round to 11.3. Next problem. Let's say that in this same triangle, let's say the angle of P measures 58 degrees. We're told that R is 5, and they want us to find P. So now I don't have a hypotenuse. That means I'm using tangent. So the tangent of 58, that's the TOA part of SOHCAHTOA. So tangent, opposite is P, adjacent is 5. So once again, I'm going to use my scientific calculator to get the tangent of 58. Well, I'm having problems typing here. 58 tangent, I come up with 1.6003. So I'm just going to use 1.6 equals P divided by 5. I'm going to multiply by 5, and I get 8. Okay, so that's a review, and as you see, we're deciding whether we're using sine, cosine, or tangent based upon the dimensions that we have. More of these types of exercises, if P is 60 degrees, measure of angle P is 60. If the length of P is 9, then they want us to find Q. So I have opposite over hypotenuse. So that sine is opposite over hypotenuse. So the sine of 60 equals that. So in my calculator, the sine of 60 is 0.86602, that's going to be 0, equals 9 over Q. I'm going to multiply by Q and then ended up dividing 9 divided by 0.8660, and I get 10.392. That's going to round to 10.4. So the length of this is 10.4. And for the last one, if R is equal to 8 and P is equal to 12, find q. For that, we can use the Pythagorean theorem. So 8 squared, 64, plus 144 equals c squared. 64 plus 144 is 208. So the square root of 208 is roughly 14.4. I'm not sure if they want approximate, which would be about 14.4, or simplest radical form. So in case they want simplest radical form, I'm going to take 208 and I'm going to factor it. It's 52 times 4. So I know that's going to be a perfect square. Okay, and 52 is 13 times 4. So 13 times 4 times 4, now this is 4 radical 13. Somebody asked me outside of class the other day, what does that actually mean? What that actually means is if you took the square root of 13, which is 3.60555, etc., 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 and multiplied it by 4, you would get 14.42. I'm actually just going to do that on the calculator since somebody asked me. I want to make sure that we understand that. 4 times radical 13. So if I took the square root of 13 is that number, and I multiplied it by 4, I would actually get 14.42, which is what I also, very similar rounding to what I got almost exactly when I took the square root of 208. So that's what that means. Let's see how they wanted it. They wanted it to the 10th, but they didn't tell me that. So that's why I did the the simplest radical form also. So that is your warm-up exercise. How to solve a right triangle. Means you find the measure of all of its side and angles. You can do this if you know either 2 side lengths or 1 side length and the measure of 1 acute angle. And in class last week, we actually talked about how to find the missing side lengths and missing angles if we had 1 side length and the measure of 1 acute angle. Today we'll also do 2 side lengths. So we have some key concepts that we need to go over. Okay? Once you know the tangent, the sine, and the cosine of an acute angle, you can use a calculator to find the measure of that angle. So basically, if tangent A equals x, so if you found this ratio, then the inverse tangent of x would equal the measure of the angle. We can do inverse sine and inverse cosine. We'll be using this. I think it'll make more sense as we use it. So using a calculator to approximate the measure of angle A to the nearest tenth of a degree. So 15 over 20 is 3/4. Okay? So 3/4 is equal to 0.75. So if I take my scientific calculator and I do, and this is actually how you do it. You're going to press the second button on the calculator. Okay. You're going to press where it says second button, and then you look at the options where it says tan -1. So you hit second button on my calculator. I put in the 0.75. Mess that up. Tangent -1, and I get 36.86989, etc. So the measure of this angle is approximately 36.9. Before, what you did is you would say, okay, I have a 37-degree angle roughly, and I'm going to put in 37 tangent, and you would get 0.7535, etc. So now we're doing the opposite. As we do it in class and you press these numbers into a calculator, it will make more sense. We can do the same thing for the sine and the cosine. So for instance, if we have an opposite length and a hypotenuse length, that when we divide them, we get 0.87. I go into the calculator, I press the second button, 0.87 sine -1, and in my calculator I get 60.458639, etc., that rounds to 60.5. Or let's say I had adjacent length and hypotenuse, and when I did adjacent divided by hypotenuse, I got 0.15. Same thing, I would go to my calculator, press the second button, then press 0.15, cosine -1. I think I did that backwards. The second button. Okay, hold on a second. I'm having an issue with my calculator, with the scientific calculator I'm using here, but it is 81. Gonna do some guided practice. I did in the meantime, while I took a break here, find that I was pressing the wrong button on my calculator when I was doing the cosine. This is why I should always wear my glasses. There's also a button on my calculator that says cosine h -1. I was pressing that and getting an error. So I make sure you press the correct buttons. So if I go back to example 1, use a calculator and find the inverse tangent to approximate the measure of angle C to the nearest degree. So if I go back to number 1, I want to find the measure of angle C. So I can use the tangent ratio again and do opposite over hypotenuse. So 20 divided by 15 is 1.3 bar repeating. So if I go into my calculator and do in the second degree 1.333333333 tangent -1, I get 53.1. And obviously 36.9 plus 53 plus 53.1 equals 90. I could have also gotten that number, obviously, by subtracting 36.9 from 90, but once again, I could use the inverse tangent of C to get the measure of that angle. Now they want me to find the measure of angle D to the nearest degree if the sine of D equals 0.54. So now I want the inverse sine. So once again, in my calculator, which actually on mine is still on the second degree, I'm going to put in 0.45 sine -1, and I get 32.68, so roughly 32.7 degrees. Next problem, solve the right triangle. Round decimal answers to the nearest tenth. So we did some of these similar, I kind of talked about them when we were during the lessons on sine and cosine. If this is 90 degrees and this is 42 degrees, I know this is 48 degrees. Now I'm going to use the tangent ratio, the tangent of 42, to get opposite, which is what I'm trying to find, over adjacent. So in this one, my variable, I'm just going to use the variable x. Now it is easier to do the tangent of 42, I find, than the tangent of 48, because it is easier, so it's just a little bit less cumbersome, I feel like, if my x is on top. Because then what I'm going to do in my scientific calculator is I'm going to do tangent of 42, which is 0.900. I'm just going to leave all of that in my calculator. I'm going to multiply both sides by 70, and I get the length of this is roughly 63. To find the hypotenuse, I could use the Pythagorean theorem, but I kind of like using trigonometry. So I'm just going to say the opposite over the hypotenuse. So opposite is 42. If I have opposite over hypotenuse, that's so in SOHCAHTOA, so I'm dealing with the sine of 42. So in my calculator, the sine of 42 is 0.66913, so 1 times x is going to equal 63. So I'm now going to do 63 divided by 0.6691, and I get 94.156, which is basically 94.2. I also could have found 94.2 using the Pythagorean theorem. I'll get my calculator on here so you can see that. Now, 70 times 70 is going to be 4,900. So 63 times 63 is that number, plus the 4,900, which is that number. I'm going to square root it, and I get, that's going to round to 94.2. So as I said, I did it by finding the sine of 42. You could also use Pythagorean theorem. I've actually gone through how to do this problem without using the steps from the book. There are the steps from the book, and they actually did it using the tangent of 42. Okay? And then also using the cosine ratio. So suppose your school is building a rake stage. That's a stage that stage will be 30 feet long from front to back. Okay? With a total rise of 2 feet. A rake, or an angle of elevation of 5% or less, is generally preferred for safety and comfort. So you need to find the measure of this angle. When we look at the measure of this angle, they gave us 2 and 30. 2 over 30 is opposite over hypotenuse. So I'm dealing with the sine of x. The sine of x is 2 divided by 30 is, when I do this in a calculator, I get 0.0666666 with a bar. So now I want to say that the inverse sine of 0.06 with a bar is 3, when I put that into the scientific calculator, 3.8225. That is less than 5%, so my rake stage falls within that error, that level of degree of elevation. And there are the steps worked out if you want to follow it through. Practice question number 3. Solve a right triangle that has a 40-degree angle and a 20-inch hypotenuse. So if this is a 40-degree angle, the other angle is 50 degrees. Now I want to get the opposite side divided by the hypotenuse. Opposite divided by hypotenuse is sine. So in my scientific calculator, I need to do the sine of 40. That's 0.642787, etc., etc., etc. I'm going to multiply that by 20, and I get 12.85. That's going to round to 12.86 or 12.9. On the other side here, I'm going to actually be to find that. That's going to be adjacent over hypotenuse. I'll just call that y for right now, just to not confuse you guys. And I'll put variable y here. And adjacent divided by hypotenuse is cosine. So back to my scientific calculator. Now I'm going to do 40 cosine, which is 0.76604, blah, 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 blah. I'm going to multiply that by 20, and I get 15.3. So those were the missing measurements that I needed. Let's see. So I have 40, 50, and 90 degrees, about 12.9, about 15.3, and about 20. Now, in number 4, what if, in example 4, another rake stage is 20 feet long from front to back with a total rise of 2 feet? So let's look back at this one. This was 30 feet from front to back. So now this hypotenuse is only going to be 20, and this is going to be 2. So I want this angle measure. That's opposite divided by hypotenuse. So 0.1, and that's sine. So the inverse sine, using my scientific calculator, 0.1 sine -1 is 5.73. So this is not safe because it is a greater incline than 5 degrees. Yay! I feel so smart. I hope you do too. Hope you are really enjoying the lesson. The daily homework quiz. So let's go over, see if we know how to do all these problems. So if x is 9 and z equals 11, find the measure of angle x. I can do opposite over hypotenuse, and that is sine. Sine of x. So 9 divided by 11 is 0.818181 bar repeat. I'm going to leave that in my calculator. I'm on the second level on my calculator. I press sine -1 and I get 54.9. So this angle x is approximately 54.9 degrees. Let's try another here. If y is 5 and z is 12, find the measure of angle x. Now we're talking about adjacent divided by hypotenuse, and that's cosine. So 5 divided by 12 is 0.4166666666 with a bar repeating. I'm going to keep that in my scientific calculator. I'm going to press on the second level, cosine -1, and I get 65.37, or roughly 65.4. I think this is the last problem. Use this diagram for exercises 1 through 3. I copied it. If y is 17.4 and z is 12, solve all of this. So if I have 17.4, okay, the sine of 17.4 is equal to opposite divided by hypotenuse. So in my calculator, 17.4 sine is 0.29904, etc., 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 times 12, I get 3.58. That's going to round to 3.6. Change colors here. And now, to do 17.4, I'm going to do the cosine of 17.4. And I'm going to call that x over 12. Using my scientific calculator, 17.4 cosine is 0.95424, etc., 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 times 12 is 11.45. So that's going to be almost 11.5. Right? So we did have 17.4. Oh, I never found the last missing angle. But 90 minus 17.4 would have been 72.6. That one's pretty easy. 12, 3.6, and 11.5. So I was able to do that problem. And now you can use these pages in order to be able to do your homework.